custom tenant internet access in VXLAN EVPN environments. This design is crucial for multi-tenant data centers, where each tenant requires isolated, secure, and customized internet access. By leveraging the VRF, policy-based routing, PBR, and NAT, we can provide a tailored connectivity while maintaining a strict traffic segmentation and security. In a VXLAN EVM fabric, the leaf node encapsulates tenant traffic and forwarded it to the border leaf. The border leaf node where the routing, firewall policies, and NAT are applied. The edge firewall here enforces the per-tenant security policies such as ACL, IDS, IPS, and deep packet inspection, DPI, before sending the traffic to the edge router. Here we say that's the PE. Okay, sending to PE for the internet access. Depending on tenant requirements, the PBR can direct traffic through dedicated or a shared internet gateway, ensuring compliance with performance and security policies. Handle the overlapping IP addresses. The NAT are applied at the border leaf or the edge firewall, translating private tenant IP addresses into public IP addresses. Also, QoS will ensure fair bandwidth distribution, prioritizing critical applications while preventing the congestion. Monitor tools like NetFlow, telemetry, and SDN controllers can provide real-time visibility, ensuring the proactive troubleshooting and optimization. After this, you will understand how to design, configure, and secure the tenant-specific internet access in VXLAN EVPN development, whether you are setting up a large-scale data center or refining a existing multi-tenant environment. So this is knowledge that will help you implement the best practices for scalable, high performance, and secure connectivity. So let's dive into this with me. First thing we'll configure is the DC2 leaf 1 and DC2 border leaf. They're in the data center 2. We'll add in tenant 3. Okay, so at a DC1 leaf 1, we'll configure a VLAN 300. Name it as L2VNI. First L2VNI in tenant 3. VLAN 2310, name as L2VNI. Second L3 L2VNI. Okay, well, I forgot to map out the VN segment 10300 VLAN 310 VN segment, that's 10310. VLAN 333 is gonna be my VLAN L3 VNI VN segment 333. So VN should run interface VLAN should run VLAN 300 310 63. Now let's take care of the interface VLAN. Interface VLAN 300. No shut. VF. I should take a look at the VRF first. VRF, say content, tenant 3, RD auto, address spamming, IPv4, unicast, route, target both, auto, route target, both auto EVPN, exits, VNI, that's 333. So run VRF, tenant 3. Here you go. Now, interface VLAN 300. No shut, VRF member, that's tenant 3. IP address 3.254. That's gonna be my fabric forwarding mode, my Anycast gateway. Interface, then VLAN 310, no shut, VRF member, tenant 3, IP address 31.254, fabric forwarding mode, Anycast gateway. Lastly, is my VLAN 333. It's my, L3 VNI interface. Show run interface VLAN 300, 310, 333. Okay, the next thing we're taking care of is interface MVE1 member VNI 10300 MCAST 225.113. Next member VNI 10310 MCAST 225.1.1.31. Member VNI 333. That's gonna just associate VRF. Show run interface MVE1. Here you go. We got tenant 1 VNI, tenant 2 VNI, and tenant 3 VNI. And lastly, only in DC2 leaf 1, I'm gonna to assign the Ethernet 1/3 to VLAN 300. Interface Ethernet 1/3 switch access VLAN 300. Save the config. Alright, now move on to my DC2 border leaf. Here you go. I'll paste in all the VLAN interface for VRF mapping. For the VNI VLAN mapping, show run VLAN 300, 310, 333. Now paste in the interface VLAN configs. Show run interface VLAN 300, 310, 333. VRF tenant 3. Go to the last bit. I'll paste in the MVE config and EVPN for RT value. I'm gonna paste in that config in my leaf 1. So we forgot the last part for EVPN, RD and RT. Save the config. Save my config. Yep. Then we'll move on to DC2 spine 1. DC2 spine 1 will configure VLAN 333 only. Name is L3 VNI 3. Because I only needs this, we need to decap encaps this 33333. Okay, VRF contacts tenant 3. We're creating this RD auto address IPv4 unicast route target both auto EVPN auto BNI 33333 should run VRF tenant 3. You will get to know why I configure this in my DC2 spine. I'll talk about later. VLAN 333 no shut VRF member tenant 3. We need L3 VNI in a VLAN interface IP forward and we interface VNE1 member VNI 33333 associate VF show run interface MVE1. Here you go. Save that config. Two interface, one goes to the EC2 and interface is for the customer XP Windows. So it's for testing purpose. We'll have to take care of the interface 10/3 IP address. Give it default route. Default route is the route to the network between DC2 WAN and DC2 border leaf. It's 128.60.100/30. 253 is on my DC2 WAN. Okay, save that config. For next, we're taking care of the DC2 WAN. DC2 WAN has two interface. 0/2 goes to the cloud WAN. So we're taking care of this first. G02. Next interface is G03 goes through the DC2 border leaf. I have to enter the IP. Now IP proxy up. Then I'm running OSPF with border leaf. IP also network point to point. No shut and router OSPF1 network. We're gonna send a default route to the border leaf. We'll have to have a default route, IP route. That's it, save the config. Next thing we're taking care of is my border leaf. Is the border leaf. Border leaf, we're taking care of the Ethernet 1/2 to the DC2 WAN. No switch. We have the member is tenant 3 IP address. We're running OSPF with my DC2 WAN. No shut this time. So run interface 1/2. So show IP route VRF tenant 3. Here you go, I got default routes. So IP OSPF neighbor VF tenant 3. Here the neighbor's up. Now we want is redistributed the BGP to OSPF, and we want to redistribute OSPF to BGP. Okay. So route map, we know we need to use route map. So route map, RMap, BGP redistribute map to where OSPF permit 10. This is my route map. We're gonna match all the iBGP. Internal route type, internal. Next route map, we're gonna redistribute OSPF to BGP permit 10. That's gonna match any OSPF. So we know the route BGP 200, right? We're gonna to VF tenant 3. Address family IPv4 unicast. What are we gonna do? We're gonna set network 0000 this. And even though default routes learned, we're gonna learn from WAN, but still we need to network the default routes. Otherwise, it can redistribute. So what I know we're gonna here have a default route. We're gonna redistribute from OSPF to my fabric BGP. That's IPv4. We're gonna redistribute to BGP, but our BGP I still need to network it. Okay. Now it's time to redistribute OSPF 1. We say route map. Which route map? This route map. No, we're gonna choose this the OSPF to BGP. This route map. Route map. This one. Okay. Show around BGP. Around BGP, we should looking at, my tenant 3. Tenant 3, I have IPv4 and I have network at default route and redistribute the default route from OSPF into my BGP. Okay, show around OSPF. I have nothing here, only OSPF. Tenant 3. Okay, so router OSPF 1 VF tenant 3, that's what I have. We're gonna redistribute BGP 200 route map. Well, I don't remember what's the route map name. Show route map. Okay, that's redistribute. Redistribute BGP 200 route map. We want is to from the BGP to OSPF. This one. So we know we redistributed all OSPF internal routes into the BGP and default route into the BGP to other leaves. We did that. And this time we're going into the OSPF and we distribute all tenant 3 routes to OSPF to the WAN. Okay. And we're gonna do one more thing is a summary. Is too many routes, right? Internally. We're gonna summarize this. We're gonna summarize tenant 3 routes and all routes ends to the DC2 WAN when not populated to the cloud WAN. So here OSPF BGP we did redistribute from BGP to OSPF, OSPF back to the BGP. If we leverage the IGP to the WAN, if it's IGP to the WAN, it needs to redistribute. For example, OSPF into the BGP. Vice versa, that's what we did. And if we leverage, if you say this is also a BGP, it doesn't have to redistribute because the IBGP populates to eBGP. There are many ways to use the route map. Match route path internal is one of them. Save the config. Go to DC to WAN and we show IP routes via F. Tenant, just show IP route. Okay. Now if I show IP routes on DC to WAN, I can see there's a route, summarize the routes 192.168.3.0/24 because I don't have detailed routes like 3.100 because it's being summarized. So if I go to my border leaf, show around WestPath. Here you go. I have summarized routes for everything. Where route from redistribute, from BGP. Do I have a list in the BGP route? Show BGP L2 VPN, EVPN is EVPN route. This one, here you go. We can see the detail of this route, 3.100. Here is the route I received from my fabric EVPN update. I can verify in my route table, show IP routes via Tenant 3. I receive a default route from OSPF also. Goes to DC to WAN. Did I populate this to other VTAP? I can verify that. Show around BGP. Where it from? It is from my OSPF, and we redistribute it into the BGP, right? Show route map. Here we're using this route map. Show around BGP. Again, we redistribute it into it, and then I advertise a default route in my Tenant 3 EVPN. We should verify that in DC2 leaf 1. Show BGP VPN for unicast via Tenant 3, and I receive this one. Show BGP L2 VPN EVPN type route type is a 5. Here you go. Is a type 5 from 6666. That's my border leaf. Okay. And is from my 4.4.4. It's a spine one. So my spine one should receive a route also. That's fine. I need a VXLAN. I need a L3 VNI, L3 SVI for decap and incap. So we'll go to DC2 spine 1, show IP routes via Tenant 3. Here you go. I have default route. Receive also from border leaf. So summarize what I did. I redistribute a default route from OSPF to BGP. Now, every VTAP gets it. And I have a tenant 3 route redistribute to OSPF to my DC2 WAN. Now DC2 WAN now can configure a NAT address translation. So we're translating on the interface this IP, we're translating the 252.2.3. Okay, we're doing all this NAT translation. Okay, on DC2 WAN, we're translating this T1 host 3.0, 3.100, 192, 168.3.100 to this interface IP. We're translating to 128.61.0.253 or 252. Okay, so now follow along and we're gonna do some NAT. For the NAT, log on to DC2 WAN. What we need to do is say no IP HTTP server for now. IP NAT inside source, say static 192.168.1.100. We'll do some 1.100 first. 128.61.0.251. We'll map it out like this. IP NAT inside source, also static, say TCP 192.168.1.200 for 28 port 80. We're translating to 128.61.0.253 80 extendable IP NAT inside source static 192.168.3.100 128.61.0.252. We'll translate to 52. That's fine. Now interface gigabit 103 IP NAT, because it's facing inside interface G02 IP NAT outside. Save the config. Now show DC2 WAN, show run NAT, show run SNAT. Here, we're translating, 192.168.3.100, this host, to IP 128.61.0.252. So now we're going to my customer WAN and I'm doing some ping. Yes, I can ping it. I can trace. Here you go. I can trace. This tells me from the customer WAN to DC2 Tenant 3 PC, I go this way and this being static netted to back to in my fabric in DC2 Tenant 3 PC. Now go to my DC2 Tenant 3 PC. I can ping 63.130.0.199. I can ping this also. Let's trace. I can trace also, and I can see my address being translated. So from a private tenant 3 192.168 range .3.0/24 range, I've been sending my traffic to the DC2 WAN through routing, right? We have redistributed and been static netted to the customer windows in the internet. If you don't believe it being translated, be netted. We go to DC to WAN, show IPNet translation. And here they're being translated. Here you go. Here you go. Look at the entries here. All right, this is the whole thing about the tenant internet access. I hope you learned something. Thank you for watching.